This lesson is going to build off a lot of what you've already talked about in Math 7. This is finding slope and y-intercept. There's a lot to cover in this one video though, so I highly encourage you to check out the videos that I put at the end of the notes. But by the end of this lesson, you'll be able to graph a line from an equation, find the slope of a line using rise over run, or change in y over change in x, and find the y-intercept of a line. Essential questions that we'll be discussing as we go through: what is slope? What is the y-intercept of a line? What are different ways that I can graph a line? And which is the most efficient way to do that? Vocabulary that we'll be talking about is linear equation, slope, y-intercept, rise, run, and change in x over change in y. The first piece that we're going to talk about is a recap from Math 7, and it's just using a table to graph an equation, so to plot some points and make a line. So we want to graph this equation y equals 2 times x plus 2. And so as a recap, here's a function table, an input-output table. And this equation is telling me that my output, my y, is going to be equal to 2 times the input, which is x, plus 2. So in this first spot on the table, I want to use x equals negative 2. And so to work that out, to get a value for y, I would say y is equal to 2 times negative 2 in place of x plus 2. Oops. And 2 times negative 2 is negative 4. And negative 4 plus 2 is negative 2. So for an input of negative 2, I also get an output of negative 2. So if I had an input of negative 1, and I'll just change colors, I would replace that x with negative 1 instead of negative 2, and I'm still adding 2. So 2 times negative 1 is negative 2, and negative 2 plus 2 is 0. So for an input of negative 1, my output would be 0. And I can go through the rest of these inputs and write down the work, or I should also start to notice a pattern. This is a linear equation, so we'll follow the same pattern throughout the entire table. So if I put in 1, I should predict first that I'm going to get 2 out, because I noticed that every single time I added 2 to get from negative 2 to 0. But let's check that. So 2 times 0 is 0. And 0 plus 2 is 2. For an input of 1, I would have an output of 4. And for an input of 2, I would have an output of 6. And now what I can do is I can plot those points and make my line. So the first thing I'll find on my x-axis is negative 2, and the y-axis value is also negative 2. Then I had negative 1 and 0. Then I had 0 and 2. And then I had 1 and 4. And 2 and 6. And so I can connect all of those points to make a line. Should make that look better. There we go. And so that's my line of this equation, y equals 2 times x plus 2. And that's just building off of filling out function tables from Math 7 and using that to make a line. This part is nothing new. But what we're getting into is ways that are a lot more efficient than this is to graph a line. So one of the new terms that we're going to be talking about today is slope. And when I talk about slope, what I'm talking about is the steepness of the line. And when I'm talking about the steepness of the line, I'm talking about how much does the line change going up and down or along the y-axis. And I'm comparing that to how much does my line change going left to right or along the x-axis. And because y moves up and down, you can think of y as the rise of the line. And because x, or the x-axis, moves left and right, you can think of x as the run of the line. So you'll also see slope referred to as rise over run. And the last way that you will see slope represented is this Greek letter delta, the triangle, which means change in y over change in x. So now that you've written down those notes, I want to zoom back into this graph so that we can look at what the slope would be on this particular graph. Okay, so in order to find the slope of this line, I'm going to pick any 2 points along the line, and I'm going to look at how that line changes vertically along y, and I'm going to compare it to how much it changes horizontally along x. So I'm just going to pick these 2 points here. And then all I'm going to do is count how many spaces did I need to move up and then over to get from the first dot to the second dot. So if I'm counting up, let me switch pen colors. I start here and I went up 1, 2, 3, 4. And now I'm on the line that the second dot falls on. And now I'm going to do the same thing counting over. I'm counting spaces, I'm not counting lines. So to get from this space to the next dot, I had to move over 2. So we would say that the change in y was 4 over the change in x is 2. So the slope here would be 4 over 2, or 2 over 1. This means that every time my line moves up 4 places, it moves over 2 places. I want to show you, though, that you could have picked different dots. You'll get an equivalent fraction, so the slope will be the same. So if you chose, let's say, this dot and the very next one, then the slope would have been up 1, 2 over 1, or just 2 over 1. So that's slope, or that is the steepness of the line. The other definition that you have, and it's right underneath slope on your notes, is y-intercept. And the y-intercept is probably a new word for you, but the y-intercept is wherever the line touches the y-axis. And so if I'm looking at this particular line, where it touches the y-axis is wherever x is equal to 0. And that point on the graph is right here. So here's where my y-axis is. And here is the point where that line touches, and in this case it crosses, the y-axis. So I would say that the y-intercept for this line is 2. Or sometimes you might see it written as the point 0, 2. So on this page, I want to give you a very brief overview of how you can use slope and y-intercept to actually graph a line without finding all of these values in the table. And so if I zoom in here, I have this equation y equals -3 times x plus 1. And I have a blank table here, and you have the skills to fill that out, use that table, plot the points, and then connect those to make a line. But you don't need to do that. So the first thing that I want to point out is this equation is written in what we call slope-intercept form. And so slope-intercept form looks like this. Y equals mx plus b. M is the variable that we use to represent slope. So the m is the slope. B is the variable that we always use to represent the y-intercept, so where the line crosses the y-axis or touches the y-axis. So in this problem, y equals -3 times x plus 1, this problem is telling us, based on how it's written, based on what we now know about this slope-intercept form, that -3 is the slope and 1 is the y-intercept. So what I can do with that, if I know that my line crosses the y-intercept at 1, at that point 0, 1, that is where I'm going to put my first dot. And I want to use the table to show you that if I put 0 in for this equation, I would have -3 times 0. -3 times 0 is 0, plus 1 is 1. So even if I use the table, I still would have gotten this point of 0, 1 that I needed to plot right there. But going by slope-intercept form is much easier. The next thing that I can get from this problem is that my slope is -3. Now, in the last example, we talked about a slope of 2 meant that every time my line went up 2, it went over 1. So a slope of -3 means that every time my line moves down 3, it moves over 1, or -3 over 1. Change in y over change in x. So what that means is now I know where my next point should be. If my slope is -3, that means I'm going to count from my starting point here down 1, 2, 3 over 1. And right here is where I will put my next point. So down 3 over 1. And let's check that. So right there is the point 1, -2. If I put 1 in place of x, -3 times 1 is -3, plus 1 is -2. So I would have gotten the same thing if I filled out the table. But what I can do now, I have 2 points, and that's really all I need in order to make a line. Let me fix that. All right, so there's my line, and if I want to keep checking, if I put 2 in place of this x, -3 times 2 is -6, plus 1 is -5. And right here, I have the point 2, comma, -5. So that's how I can graph an equation using just the slope and the y-intercept. So let's talk about, and this is below on your notes, how we can use all of that to actually write an equation of the line. If I gave you 2 points, we can graph those 2 points and figure out what the equation of the line should be. So here I have that a line passes through the points 0, 2 and 3, 8. And we want to use those 2 points to write an equation in slope-intercept form. So the very first thing I need to do is plot those 2 points. So here's 0, 2, and 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And let me make a line. All right, so what we talked about was now we know that slope-intercept form looks like this. Y equals mx plus b. And let me type in case you didn't get this, that m is equal to the slope and b is equal to the y-intercept. So from my graph, the first thing that I can see is that the y-intercept is right here. This is the point where the line touches the y-axis. And so that point where that's happening is 0, 2. And so in my equation for my y-intercept, it's going to be y equals something times x plus 2, because that's where my y-intercept is. Now I need to figure out the slope, and so I can just count to get from this dot to the next dot. I had to go up 1, 2, 3, 4, 5, 6, and I had to move over 1, 2, 3. And so my slope is 6 over 3, or 2 over 1, or we can just write 2. And so in my equation, my slope, my m, is 2. And so this equation is y equals 2x plus 2. I really want you to watch the other videos that I've posted as you are completing the IXL practice. This was a really big skill from IM, so you're probably going to need. Please take advantage of all of these practice areas on IXL. We talked a lot about this in IM, so you miss quite a bit of chances to practice. And there are 5 videos there that I recommend if you find that you need some extra help. So please be working on these over the next couple of weeks.